So he's just doing 1, 2, 3, and 4. Okay, for number 1, will you show me what you got? And when I say show me, like, hold up. If the answer is negative, by the way, -1. So this is just saying, I want to see what's happening to this function as x approaches 0 from the left. So my focus first goes to right here, and I just say, hey, where's the function? The graph, it's up here. It's a little bit more than 3. And as I approach 0 from the left, you can see those values are kind of settling in to 3. So you are correct. How about on the right side? Also 3. And make sure you're putting equal signs here. Equals 3. Now x approaches 0. Do we have an answer for that? Yeah, since they match. And I'll write this here. Since left and right match. The answer is 3. So far, so good? Once you see it, it should be pretty easy. F of 0 is 3. Okay, before we go on, let's read this little blurb. We want to limit to be the unambiguous solution. A function settles down towards as we approach the desired input. Where does the function settle down? Because of this, if the left-hand and right-hand limits do not agree, we say the limit does not exist. Have you heard that before? Have you seen it? It was a movie. Mean Girls. If you haven't seen it, please do. It's fantastic. But the movie Mean Girls immortalized the phrase, now we will understand what it means. So because these limits are the same, this limit does exist, go ahead and try 5 through 8. There is one typo. Let's see if you can find it. A typo in the problem itself. Yeah, number 8. Yeah, it should be nice. You guys are quick. The f of -2. Okay. Would you please show me what you got for number 5? -2 from the left of this function, -1. Are we good with that? You need to think about these as functions with me, which means they have inputs, outputs. These inputs itself is by definition, we're going to -2 from the left there. But in this one, oh, that's kind of low. In this one, we're going to -2 from the left. How low does this get? -1. Right, what does this circle here represent? It's a hole. How big is that hole? 1. Which is how big? The size of a point. This is how big? That's not it's an object. That's not located. It's called an infinitesimal. It's infinitely small. Alright, so this circle that represented is huge compared to what it actually is. Right? So this, by the way, this graph looks just converging on the left. How about from the right? Also -1, so you put a -1 here, equals -1, equals -1. How about number 7? They match, that's what's -1, but f of -2 is also -1? That is 1. We don't care what's happened to the left or the right. We just care what happens when you plug in that -2. There's nothing down there, but there is a point. And that value is 1. Try 9 through 16. Oh no, it's it's pretty. I'm telling you, yeah, you can't go, yeah, exactly. You can't go to 3, you can't go to 4. Yeah, I can't say it, then it's so hard. No, the limit from here, you can't go to like 3. It's not even close to the 8. It never comes in between. If I get close to it. Are you ready? It sounds like there's some controversy. Number 9! Number 9, would you please show what you got? Number 9? Or 2. Number 9. Take 2. Yes. Approaching X is approaching 2 from the left, so right over here, approaching 2 from the left. Yeah, it's 22. Does it actually hit that 2? No. Doesn't have to, but it looks like it's going to land there. It's going to like land there right to it. 2 from the right. Show me what you got. Yeah, show me that. Yeah, it's 1. It's increasing very quickly there, but yeah, it looks like it's just. So what would we say for number 11? The limit does not exist. So what we do is write D and E for does not exist. There is a difference. Yes, it is incorrect. So if they don't match, if you see that 2 and 1, I need you to say does not exist. Undefined is reserved for, what is undefined? When 0 is in the denominator. We don't have any case like that in this case. F of 2, do we know what that equals? It's very definitely equal to 1. We can see it clearly with that closed circle. The next interesting place is around -1. What did you get? Could you show me what you got for number 13? Nice. Yeah, you need 2 hands for this one. I have no idea how to do this with a single hand. Infinity. Does it go all the way up to positive infinity? How about on the right side? Infinity. So 15? They match. It's infinity. F of -1? Undefined. Or you could say -1 is not in the domain. Would it be appropriate to say does not exist? F of 1 does not exist?
No, because it's
So would it be okay to say does not exist? If it's the question that's for F of 1? But we're not looking for 1, we're looking for F.
Oh, yeah,
F of negative. So -1 is on a number line, but if I try to find a point, either above it or below it, does that point exist? No. But I would buy it if you say does not exist in that case. Although it generally does not exist, is reserved for the situation I'd accept it here. Undefined or valued out of the domain or it does not exist is fine. Because it literally just does not exist. But please don't use undefined for a limit. So please be careful. Any questions? Okay. I'm going to resume at 12:30 if you want to zone out right now or stretch. Put your heads down. You may. Yeah.
I'm testing problem. I had project this, my project was like that, so I was so good. And I tested it with that. Not good enough. Actually, I can test it. But it's fine. It's okay. It's fine. Well, I did well on the quiz and the film test.
Oh.
It's like,
Yeah, the quiz for this test is not good.
the one page, I was like,
Yeah.
this is definitely not
I was like,
full
I
PDF.
just forgot a part.
But I don't want to do the personal math because I don't really get that.
I would have to I would take care of it.
Yeah.
How was the concert?
Oh, it was so good. It was, I was like, it was really cool.
I heard it came home as soon as I was in college after school.
Yeah, that was, it was a really good experience. that was like quarantine. So that's when it's like the pandemic, so it's really like fun to see it. And I had a really good crowd. They would keep the he came to the crowd, like he'd sing, like he walked around.
Really?
Yeah, it was really fun.
Especially like classic group are these like typical Jewish cookies?
Oh, Jewish cookies?
Yeah.
There's a brand of these.
But like there's some of the jelly.
Like the Orthodox one. Okay. So, a reminder, that short break that we have is not necessarily for you to go outside. You may, but if I hear any complaints from teachers in terms of talking in the hallway or just disturbing other classes, I'm going to say no departing class at all. Okay, so just, if you're going to leave, just make sure that, like today, you are back on time. Thank you very much. And that you're being respectful of the other people here. Okay, let's, where are we going? Page 16. Page 16. Does this graph have a parent function? Actually, before we do this, let's go back to the page we were doing before. I'm sorry. I forgot. I want to do a couple more here. I'm going to change these. Instead of 1 over x, let's make it 1 over x minus 3. Does that have a parent function? Yeah, that has a parent function. And this one, 1 over x plus 4 squared. Does that have a parent function? Let's graph these, and I'm going to look for 4 limit statements for each one of these. 4 appropriate limit statements for each one. Maybe you want to sketch a little graph, I don't know. This first one has an asymptote at, a vertical asymptote at 3. Four limit statements each. Four interesting limit statements each. Exactly. So I hope you're considering x approaching infinity, x approaching negative infinity, also x approaching 3 from the left. And 3 from, actually, let's do 5. Let's just do limit as x approaches 3 also. 5 limit statements each. Why hold back? These are all functions, so of f of x. The order doesn't matter. You can do these in any order.
Okay, when x goes to infinity, y is that the number? So y goes to y.
Okay, so I don't know what order you did them in. But as x goes to infinity,
And when x goes to
the function is approaching 0, negative infinity. 0. Now, some people might like to put a plus there and a minus there. Would that make any sense? It's actually appropriate, but if we think about this as, yeah, this would mean that it's approaching 0 from the right. This is y though. We're not talking about left to right. We're talking about above and below. So this means 0 from the top, which is actually appropriate but very unstandard. So you might see it from time to time, and I would never ask you to put it there. But then on the other side, then considering that, well, that makes sense. It just be 0 from the bottom, from below to the bottom. If you want, you could do that. It's kind of fun. Of course, as x approaches 3 from the left, we're dealing with, it approaches negative infinity, and the next one is x approaches 3 from the right. Positive infinity, so the limit as x approaches 3 does not exist. This other one, these are both 0. Did you graph it? We know that it looks like, negative 4, excuse me. I forgot to shift it. I was in the parent function. Negative 4. Shift it to the left. So these are both 0. If we wanted to, we could put 0 from above and 0 from above also. X approaching negative 4 from the left. Infinity, the other one. Infinity, so finally, infinity as well. So hopefully that was very straightforward, easily understandable. Let us move to this next set. Sorry to bounce back and forth. Sometimes you just gotta go in a way that makes sense to you. So back to page 16. You notice that we don't have a parent function, but we do know one thing about this graph. We know the domain is x does not equal 1, which results in an asymptote. So vertical asymptote or x equals 1. So I'm going to make this number line. I'm going to put a 1 right here, and I'll put an asymptote. Now, I'm not actually going to graph this, but what I'm going to do now is analyze behavior of this function around that value. Are we okay so far? And I just want to know, it's asking about describe behavior near the vertical asymptote from both directions. So although we could do 4 different limits, I'm just going to do 2. I'm going to do the limit as x approaches 1 from the left. Again, I like to go left to right. And I'm going to do the limit as x approaches 1 from the right of f of x.
So when it says describe the behavior, how do we know which one's the
You find a domain. And this is saying describe your behavior from here. Near the asymptotes. I want both directions. Yeah.
Okay.
Right near the vertical asymptote. We definitely want it says from both directions. So let's do that first. If x is approaching 1 to the left, what kind of numbers are we talking about? Like 0? Yeah, 0.1, 0.999. Are we okay with that? Our eyes up here. So if I put a 0.999 right here, I'm going to plug that in here. It makes sense the top is basically 4. I'm not going to say the bottom is basically 0 because there is something. We have 0.999 minus 1 is going to leave us with a tiny negative number. So if we have 4 over a tiny negative, what's the result there? Huge negative number, negative infinity. Just like we were doing in the warm-up, except this time we're just dividing 4 by a negative number. So that's going to be negative. And the closer we get to 1, that smaller is one that that denominator is going to get, whereas the top just stays basically 4. On the other side, we're plugging in numbers like 2. 2 is quite far away. 1.00001 minus 1 leaves us with a tiny positive number, whereas on the top we're left with basically 4. Right? 1.00001 plus 3 is basically 4. That doesn't change that value from just having 1. Like that 1.00001 minus 1 leaves us with a tiny positive. So we're left with 4 divided by a tiny positive, which is why this will give us infinity. So on the right, it would look something like this. On the left, it would look something like this. I don't know the other behavior. We will be talking about the rest, but I'm just wondering about what it's doing near that vertical asymptote. And there are different options. I forget if I've told you my convention here. If I'm approaching that asymptote, I just write the half arrow. And that's another thing. Put that half arrow 1 because there's no room for the other side. Because the vertical asymptote's in the way. And just also to acknowledge the fact that I actually am approaching that, to acknowledge the fact that I'm approaching it. So that half arrow on it. It's not standard. You may or may not do it. It's completely up to you. Other teachers might be confused if you do that in another class. Although here, I think they're pretty much used to it. Because there are a few who do it. Are we okay with this so far? I'm going to change this next one and look at x squared minus 9. Discuss the vertical asymptote. Are there 2 of them? Yeah. So how many limit statements will we need? 4. Are we already ready to discuss?
Yes, positive.
Oh, 9. So that's okay, that's over.
Yeah.
So that gets you so small part. So small part of
I guess it's all Ten seconds. Okay. Attention, please. And it's really nice when we have a graph, isn't it? It's nice to do these when we have a graph because you just look at it and see where it's going. If we don't have a graph, do we use a parent function or something? No, there's no parent function. Craziness happens. And so we have to analyze just by using numbers close to what we're talking about here. So again, I'm going from left to right. That's going to be -3 from the left. If I'm talking about -2 to the left, the numbers I'm thinking of that I'm going to plug in just in my mind are negative 3.0001. Yes? So the top is basically -3. But what's going to happen to the bottom when you plug in something like -3.0001? When we square it, it's going to be a tiny bit more than 9, won't it? Then we subtract 9, leaving tiny positive. Tiny positive. So that's just called analysis. I'm definitely not doing anything like trying to figure out what -3.00001 squared is. I'm definitely not doing that. I'm just going to say it's a little, tiny bit more than 9. So tiny positive, this leaves us with negative infinity. How about the other side when I'm doing -3 from the right? Finding numbers like 2.9999. When you square that, it's going to be a little bit less than that. It's maybe like 8 points. Something crazy, bunch of 9s. So you subtract 9, you're left with tiny negative. So we have what's basically -3 on the top over a tiny negative leaves us with a huge number. And if you follow that, 3 from the left, it'll be 3 over tiny negative. Is that right? I think that's right. Then from the right, basically 3 over tiny positive. So it would look something like, it's like this, and then here, and then here. That's what the behavior would look like. And we will get to graphing these eventually, but all I want to know is where is it going? Positivity, negativity, etc. Or maybe not infinity. Any questions? This work here, with the words tiny, that can remain in your head. You don't have to write that out. Unless you want to. But if I'm not sure where your answers came from and I ask you, like on the test, where did you get this answer? You have to be able to explain how you got infinity, where that negativity came from. So kind of go through their calculations. This one, where are the vertical asymptotes? Nice. It'd be I and negative I. Could we graph those on a number line? Yeah. No vertical asymptotes for this one. Abbreviation for vertical asymptotes? VA. There are no real numbers for which this is equal to 0. And finally, I'm going to switch. I'm going to change this again. Instead of x squared minus 9, I can do x squared minus... Actually, let's do minus 9. I'm sorry, you probably crossed that out already. This is interesting if we do a 9. So we're left with x minus 3, x plus 3 over Okay, discuss vertical asymptotes.
There's a whole bunch of them. So, you know, it's just I don't see why you really kind of find
Okay, so in this case, vertical asymptote, and just x equals -2. So x equals 3, is that a vertical asymptote? Oh. Let's analyze though. So I'm not going to cancel it. But I'm going to see what's happening here at -2, and I'm just going to mark this for a minute. -2, the limit as x approaches -2 from the left of f of x. Did you get it? -2 from the left, -2.00001. These are going to cancel, so I'm not even going to try to move them to cancel. But I will do this for now. They're always going to cancel. We might as well just cross them out. Or cross them out. -2.001 plus 3 is about 1. And that's not going to change much. -2.001 is just a tiny negative. So we have a positive over a tiny negative. Negative infinity. X is approaching -2 from the right. -1.99999. Didn't cancel no matter what. 1.99999. Basically 1 over a tiny positive, which results in infinity. The limit as x approaches 3 from the left. Yeah. Comes to 3 from the left. So like 2.999. So a tiny negative over or it was basically 5. So is it 0? The 0's on the top. Did I do that right? I'm sorry, it's not 0. What am I talking about? 2.999 is 6 over 5, isn't it? I'm sorry. 2.99999 plus 3 is basically 6. 2.999 plus 2 is basically 5. There's nothing that's sending it to 0 or to infinity. It's just landing on 6/5. And as it approaches 3 from the right of the function, 3.00001, 6 or 5.
Could you just plug it in, like, the function, and that would be
We can't plug it in here.
Or to the,
No,
to the, to the simplified.
so we could plug into simplified, and that's exactly what the limit would be. If we're just going from both sides, so if we have the limit as x goes to 3 of this function, it is 6/5. So yes, on the graph there would be a hole at 3, 6/5. We'll talk more about that next time. I do have assignments for you up on my math items, but it wasn't up last time. There are 2 different assignments up, so make sure that you're paying attention to both.
The 2 new assignments?
2 new assignments, yeah. One on rational expressions and then another one on limits. So,
How long?
both you next time.
Are they both shorter?
It won't take you more than an hour and a half. Total. It should take you less than an hour. It should take you less than an hour. Have a good day off. I'll see y'all on Friday.
So,